Hi Evergreen, let's learn about Chapter 9, Lesson 3, Triangles. Now, triangles are something that you are also very familiar with, but we are going to be learning about how to find the area of them. And you probably already know this as well, but just in case, we're going to study. And so let's look at Theorem 38, and we're also going to look at Theorem 39 in a second. So let's look at Theorem 38 first. Let me try to isolate this. There we go. Okay, so Theorem 38 says the area of a right triangle is half the product of its legs. So remember that a right triangle has legs as these straight sides next to the right angle. And this diagonal created between is the hypotenuse. And so given that triangle ABC with legs A and C, we have this formula. So 1/2 BA. So 1/2 times B times A will give us the area of triangle ABC. And so the following figures show the plan of the proof whose main ideas are outlined. And so if we used this triangle and we kind of doubled it to make a rectangle, and we noticed that they marked that the BD and AC are parallel, and also AD and BC are parallel. Now when they did this, they marked the right angles in each of these corners that were created, and they marked that these line segments are equal and the hypotenuse is sharing this side, and so therefore, of course, it is equal between both of these triangles created. And so looking at this, we have these proofs. So through AB, draw lines parallel to the legs of the triangle to form a parallelogram ACBD. ACBD is also a rectangle, right? So a rectangle is a parallelogram. And so therefore the area of ACBD is equal to B times A, right? If we were trying to find the area of a rectangle, we'd say base times height. So triangle ABC is congruent to BAD. And so therefore the area of ABC is equal to the area of BAD. And so therefore, the area of triangle ABC is half of the area of the total rectangle ACBD. And so the area of triangle ABC equals 1/2 base times height. And so they're showing you all the proof of why this is the formula for a triangle. You need to make sure you know the formula for a triangle by heart. 1/2 base times height. And now you know why it's 1/2 base times height, because it is half of a rectangle. Now, let's move on down to here. Let's read this page together. Woo! Okay, there we go. So, knowing this formula for right angles, we can derive a comparable formula for the area of any triangle. Let's look again at this right angle down here, ABC. If leg AC is the base of a triangle, it seems reasonable to call the length of the leg BC its height or altitude. Remember, those are synonyms of the triangle. So height or altitude is basically how tall the triangle is. And in general, we think of an altitude of a triangle as the distance from a vertex to the line on the opposite side. The distance from a point to a line is measured along the perpendicular from the point of the line. Consequently, the word altitude is also used to refer to the perpendicular line segment from a vertex to the line of the opposite side. And so, if you have this type of triangle that is not a right triangle, you need to find still the altitude. And so the altitude will not be one of these lines. We just get lucky and have an easy answer here for a right triangle. But for other types of triangles, such as DEF or GHI, the altitude is simply how tall the triangle is, and that might not necessarily be a side of the triangle. So for here, you would have DE, you'd have a measurement for this side, you'd have a measurement for DF, you'd have a measurement for EF, and you'd also have a measurement for the height or altitude. And the same is true for this triangle GHI. You have the segment HI, you have a measurement for this, you have a measurement for GI, you have a measurement for GH, and it is different from the height because that is telling you how tall the triangle is. And this is a different measurement than GH, for example. Okay, so make sure you always know the distance between, or the difference between the height of a triangle and the length of one of its sides. Let's go over here to Theorem 39. So Theorem 39 says, the area of a triangle is half the product of any base and corresponding altitude. So this is just saying in words the formula for finding a triangle. An immediate consequence of this theorem is the following corollary. Corollary to number 39. The triangles with equal bases and equal altitudes will have the same area. So even though triangles can look very different, if they have the same base and they have the same height, base times height, and dividing that by 1/2, this will have sometimes surprising equal areas. Okay, guys, you did great. Let's jump into solving some problems.